It's very simple until we get multiple teams involved. Well, if anybody does, we'll be there right there in the corner. Jim, Brian, and myself will be more than happy to speak to you. Thanks for your time, folks.
Great, thank you, Dan. Brian. We're going to shift gears a little bit here. Then we're going to go to a break, so we're almost there. We did there's been a survey that's been done, and asking what is the biggest hurdles that the growers are facing, and it came out with labor number 1, water number 2, and regulations number 3. And so on labor, the 40-hour work week, lack of available labor, minimum wage increase are all putting stresses on you. And as Christine mentioned a little bit, there's looking like a time of use, time change coming in the future, which is going to move from noon to 6 to sometime later in the evening, because our peak has been shifting. It's been shifting slowly more and more to the evening time when people get home from work versus during the hot part of the day. It's always be air conditioning load that was the biggest cause of our peak. Now with all the solar we have online, well, that actually the peak is kind of occurring when everybody gets home and into the evening. So it's kind of a double-edged sword. But that shift can also put hurdles onto your labor, because instead of sending a guy out at 6 o'clock, which is already late enough, if you wanted to avoid peak, you'd have to send him out there at 9, 10 o'clock to change water or something. So that's something that we recognize is not a good situation for you guys. So a lot of what we're going to do today is try to talk about things we can do with automation, tracking start and stop pumps remotely, and that's kind of the theme of a lot of this discussion here today. On water, it's always going to be an issue. Hopefully this is going to be a great year, which it looks like it. We do have our APAP program, which is run out of Fresno State. It's Advanced Pump Efficiency Programs, and that is a great program to participate in. It helps you subsidize pump testing, so you get a test on your pump, get the efficiency tested, and then if you do need to make some repairs, it is a program that allows for you guys get a little subsidy for repairing the pump too. So that's the water side, and then the regulations, complying. We're not experts in your field, and but I know there's a lot of regulations that you guys are going to have to adhere to in the future, whether it's reporting how much water I'm using, or nitrates, how much am I applying on the ground, is it turning out neutral in the end, is the plant using it all up? So there's lots of requirements that are coming at you, and I think a lot of these new companies that we have here today that they're monitoring, they can monitor water, a variety of different things, and I think that there'll be a benefit for you to comply with whatever regulations you have to adhere to in the future. We have energy component, and it's your data, so the only person that we can share your energy data is with you, or if you assign somebody else that we can share it to. So you could sign off and say, we'll go ahead and share it with these other people. So a lot of these guys, if you take our energy data, monthly usage, or interval data every 15 minutes, and then you tie it to a pump test or some sort of a pump test, well, you can monitor when you're using water, how much water, and use that as your reporting requirement. So you can create reports that you need to turn in to whoever. And again, it's not our deal. The only contract we have is with you personally. Your data is your data. It's not shared with anybody else until you say it's okay to do so, and you need to sign a release to do that. So with that, I was I thought maybe we'd just go over what is a pump test. I mean, we talk about it all the time, but what exactly is a pump test? And basically, it's a way to account for all the losses when you convert from electrical energy into mechanical energy. And so in a perfect world, you put 100% energy in and you get 100% out. That'd be the work that you get out of it. but it's not a perfect world. So just for an example on this, there's a motor loss of 10%. So if you put in 100% electrical energy, so this motor is the efficiency rating is 0.90, so it's a 90% efficient motor. So it's using 10%, just converting the electrical energy into that output shaft. And so just right through the motor, you put 100% electrical energy, boom, you're down to 90%. Then you go through some bearing and shaft losses, you lose a couple more percent. You keep working your way around, you get friction losses, you got another huge one is the pump itself, about 13.5% on this example. So that's usually the largest loss within the system. This conversion of electrical energy into mechanical energy is usually at the pump level, and 13.5%. But you work your way around the whole cycle, you get all your friction losses, this and that. And in this example, it's 71.5% overall plant efficiency at the very end. And that's when everything is in perfect working condition. That's like brand new right off the showroom floor. And your pump is designed for the situation that you're operating under now. There's a pump curve too, so you got to watch that. Your efficiency at design could be 13.5%, but if we've had a real big drop in water levels or there's a big change, well, you could be off that pump curve. And instead of having a 13.5% loss on that particular pump model, you could be off, say, 20-25%. But that's something that gets picked up within a pump test. And so it's always good, whether the pump's in good shape or not, but just even changing water levels is always good to try to get these pump tests every couple of years. And we help to subsidize them through APAP and just see where you're at. And it doesn't tell you why you're at that level, but it gives you some clues. So it just kind of, if you say, hey, well, shoot, this thing's at 50%, I wonder why. And then you start looking at the pump curve and looking at the water levels and going, well, it's not really operating the way it was designed. Or the situations have changed so much that the design is not. But we may need to put in a new pump to get this thing back up into a higher efficiency range. So go ahead, Jeff. And this is, oh boy, that's big. Then this is an old pump test, but they're all the same. I mean, you can get a pump test from lots of different companies, and it doesn't, the format's a little bit changed, but they always tell you basically the same thing. And this one here, again, you're looking for the overall plant efficiency, and that's so 35.6% is what this pump tested out at. I think it was 75 horsepower. But it gives you your water levels, pumping water level, static water level, tells you your drawdown. This was in the Salinas Valley, so there wasn't a lot of drawdown back then in '92. Tells you your flow rate, average cost per kilowatt hour, or kilowatt hours per acre foot. So that's a great number to have. And we can take our energy data, tie that in there, and then get your, you take your total energy, divide in the kilowatt hours per acre foot, and tell you the number of acre feet you guys pumped in each month or whatever time interval that you want to use. But along with the pump test, and most of them go to potential savings, and we try to estimate, okay, present conditions, this thing's pumping 35